Hello and welcome to the Viking Motorsports Manufacturing Subsystem. My name is Julian LaRue. I am the manufacturing lead. This is the first year that this subsystem has been introduced, and this video will showcase a little bit about it. I want to highlight a couple of reasons why we decided to include an entire subsystem for manufacturing, some of the manufacturing mistakes we've made in the past, along with how this subsystem will operate this year. I've been with the team since 2017 and previously worked on the design of outboard suspension. Some of my designs are shown here. They may look relatively simple, especially if you were planning on 3D printing them, but there are fundamental issues with each of these that would otherwise make them difficult or impossible to manufacture. As a designer, it can be really easy to overlook the manufacturing aspect. It's also a specialized knowledge set, some of which only comes from experience. VMS is limited in the amount of time and money we have to spend on the design and manufacturing process, so issues with the manufacturing can cause budget issues, as well as the worst of all, which is not getting the parts we need manufactured by the time we are supposed to have this car at competition. This is one part of what happened during the 2018-2019 design season. Some of the parts on this screen are responsible for this. In April of 2019, less than 3 months from competition, we found a machine shop willing to sponsor us and machine these parts. I sent him the part files and met with him to discuss the machining. What I didn't expect was for him to give me a couple pages of issues with my design that needed to be fixed before it was possible to manufacture. The list even grew over the 3 weeks that it took him to go from the part that was submitted to something that his Haas 4-axis CNC could actually produce. Because of the design, it also required almost $400 in special tooling that we did have to pay for. Basically, I wish that I had known all of this before I had sent him the part. In all reality, this was already happening way too late. The car needed to be done in 3 months, and it was clear that that wasn't going to happen. 2 years worth of design work and preparation gets quickly halted by designs that have not considered the manufacturing. Of course, the parts that I designed were not the only problems that we faced. Tasks such as welding the tubular chassis seem easy in the design phase, but actually coordinating the welding accurately requires some assistance. In the left picture here, this water jet cut wooden chassis jig is supposed to hold all of the parts in place for welding. This design was good in theory, and it was very cheap, but the assembly of the jig itself proved to be very tedious, not to mention left us very little room, no room for adjustment. More thought and a little more money put into design, and we could have created something more useful, maybe similar to what you see on the right there. This will be a capstone 2021 project that will hopefully result in a jig that we can use for all future years, but it will be the responsibility of the manufacturing subsystem to make sure that the jig works for the new design of the chassis. The manufacturing subsystem then was created this design cycle to make sure that the problems we have faced in the previous design cycle do not happen again. We will be fundamental to the design of the car throughout the entire process, and when that winter manufacturing season starts, nothing we face should be a surprise. Some of the goals of the manufacturing subsystem are to help the design subsystems create those designs for manufacturability. This involves thoroughly looking over and critiquing all parts that we plan to manufacture for the car. We as a subsystem also want to provide members with resources and knowledge to design things with these manufacturing issues in mind. It is important to build up a wealth of manufacturing knowledge and experience for future design seasons to refer to. We have started producing a handbook known as the DFM handbook that is designed for manufacturability. We also plan to produce a time budget calculator that stores data such as how long certain parts took to manufacture, all to help with future manufacturing seasons. We're also the ones putting together the schedule. When winter manufacturing season starts, all of the team should know which things are getting made this week and next week, how it is being done, and how long it should take. Certain designs may require special tooling or fixturing that needs to be manufactured first, and we want to make sure that we know about these things and that they get done. All of this should happen before that winter design season starts. All members of the manufacturing subsystem should eventually be experts in manufacturing. It may be difficult given the current situation and our extremely limited access to our workspace and shop, but all manufacturing members should be able to look at a part and start to build a plan of how that is going to get made. Hopefully we can share this knowledge with the entire team so that everyone leaves VMS with some actual manufacturing experience. Showing a hiring manager pictures of things you have actually made makes you look really good. So to give an example of the kind of design decision that might affect the manufacturability, take this strange looking bolt head retainer, which is designed to stop the bolt head from turning so you can tighten it without access to the back. And maybe I got the size and dimensions of here from the bolt head, and this is a radius of 1/32. Now VMS has access to an 1/8 inch end mill, but we don't want to use that because it's going to make the radius in here a lot larger, and then our bolt head will not fit. We might have to enlarge the design. That's one choice. The second would be to purchase another sized end mill. First we need to look at the fact that this dimension right here, this depth, let's call it 1/2 of an inch. If we were using the 1/8 inch end mill, we can look at the data sheet and see this length of flutes as 1/2 of an inch. That basically means that you can cut 1/2 of an inch deep. Now, if we want to buy this 1/32 end mill, we'll have to look at the same data sheet and see that the length of flutes is only 3/32. Now that's not gonna work. One thing we could do is purchase an extended one, a sort of specialized one. Now, this has a 3/8 depth of cut. We could probably get away with this, but now we're looking at $50, so it might have been better to make that design decision in the first place. Another design issue you might run into is the issue of steel, which is much harder to machine than aluminum in a lot of cases, but especially hardened steel. This hub design needs this drive shaft tulip to ride on the inside surface here, and because of that it needs to be hardened or else it would wear very quickly. And you can buy hardened steel, but you can't machine it after it's been hardened, so you must buy annealed steel, machine it, and then harden it. So basically straight away you know that this is outsourced. So this is my upright. This is the part that I actually had him machine for me and give me all of that feedback on. And this is definitely one of the most difficult parts to machine on the entire car, and will be for the future one too, probably even more so. We start with the 6061 T6 bar stock and clamp that in what most mills would use as a vise, such as this Kurt. It's really good for clamping bar stock, but we run into problems when it comes to the geometry of the upright itself. See, we have this taper off of the center, which means that if we clamp it in the vise, we won't be able to machine out this section because it will be obstructed by the vise. We also have this vertical section that we could theoretically clamp to, but our vise might not be big enough for that. Belfonte Machine Works' solution to the issue of clamping the upright was to buy another bar stock of aluminum and put dowels in it. So he requested that we change the design to put holes to locate the dowels on the upright, and then once the upright was mounted to this block of aluminum, he could use that to change the position in the mill and also hold it throughout all of the features, because now all of the sides are completely accessible. This is the kind of fixturing device that if we were machining this ourselves, we would want to have a plan before we actually get to the machining stage. I just showed some specifics of what kinds of designs might be bad for manufacturing, but this flowchart shows some specifics about how that fits into the design process. All designs start with that idea within the subsystem and preliminary designs, and then these designs will go through natural iterations and changes before they are sent to us to be checked. This is where resources like the DFM handbook should be useful to the designers to keep the manufacturability in mind, even when starting the design. The fewer changes we need to make for manufacturing, the quicker we can start to build the part. When the subsystem has finished the part and thinks that it's ready for manufacturing, We will critique the part and try to find any problems. If there are, it'll be sent back for redesign. We will help them make sure that it is 1. Manufacturable, and 2. The best that it can be. That is, the smallest waste of material and time, and the fewest special tools that we need to purchase. Another important decision we must also make is whether VMS actually has the ability and time to manufacture this in-house with our little 3-axis CNC, which is usually occupied by graduate students. If the part will need to be outsourced, we need to let the subsystem know early so that they can budget for that and start looking for sponsors. Those sponsors might have their own design changes to make. That's why all of the steps I mentioned should happen before the design deadline, so that we are making design changes that affect other parts of the car before those parts are finalized. When all of this checks out and the part is ready for manufacturing, it will receive our check and we can start to build it. I hope that we can get back into our lab and machine shop this winter and actually get our hands on some machines. But if not, that should not stop us. We have members who have special access to machine tools and spaces to work in. Hopefully this car will get finished and the manufacturing subsystem will be there to help make it happen. So I would encourage anyone to join, even if you have little or no experience. That's sort of what this whole thing is about, is to help give people these skills. There's a place on the team for everyone, and all of our members are invaluable to our success. And I hope that all members of VMS will be able to take these skills that we learn here and apply them to our future. Thank you.